What's up guys, Major Math with another video on fluid mechanics. If you have any questions, drop it in the comments, and if you're having trouble with other problems, I've attached my email in the description, so please feel free to reach out. Without further ado, let's get started. Question 1.29 in the textbook says, what is the specific weight and density of air at an absolute pressure of 730 kilopascals and a temperature of 28 degrees Celsius? First step, write down our goal, find specific weight and density of air. Given, what are we given? We're given that the pressure, absolute pressure is 730 kPa, which is equivalent to 730,000 pascals. Just kilopascals, just that kilo just means pascal times 1,000. So we can do that, and then it gives us that temperature is 28 degrees Celsius. We're gonna need to convert this to Kelvins later, so I'm just gonna go ahead and do it now. And to do that, all you do is add 273.15. So I'll write that out. And that will give us 301.15 Kelvin. Okay, so that's what we're given. So it says we need to find the specific weight and density of air. Okay, so let's write down what's the formula of specific weight is density times gravity. So see, it seems like we have to find density first before we do this one. So what's the formula of density? Mass or volume. But we can't, there's no possible way to find mass here or volume. So this equation doesn't really help us. So we got to figure out another way to use density. So that way we're going to have to use the ideal gas law. The one we're going to use, there's different versions. We're going to use this one. Right. Okay. So this one's better because we have pressure. We don't have density. That's what we're going to be solving for. We can get R from the textbook, and we have temperature. From the textbook, the specific gas constant is 287.0 joules this is just, instead of writing a fraction, I'm just putting a multiplying and put a negative exponent. So you could also write it as a fraction and have no exponents. I just wrote it like that. Okay, so we have everything we need to solve for density. Let's go ahead and rearrange this. So we have, we'll do density equals pressure over specific gas time. Okay, so we'll have that. Let's go ahead and plug our numbers in. Our units aren't matching up. We know that pascals are the same thing as newtons per square meter. So, and then we know that a joule is equivalent to newtons times meters. Okay. The temperature. Okay, so our units are looking better now. These will cancel. We'll have a meters cubed for volume. Then we'll be left with kilograms on top, and these will cancel out. Okay, yeah, so that'll give us our density. Put it in the calculator. We get that the density equals 8 0.45 kilograms per meter cube. Okay. So there you go. That's the answer to the first problem. That is the density of air. Now we gotta find the specific weight. So specific weight, I'll write it again. So we know gravity, and we just solved for density. So we can go ahead and plug those in. .81 meters per second squared. I just got that you guys should probably know this by now, but I just got that from the textbook. It's just a constant we should all know. Again, our units are kind of funky. So in the textbook it says 1 Newton is equivalent to kilogram times meter per second squared, right? So this will really help us. So let's multiply this out. We'll get 82.9 kilograms meter times, right? And we can simplify this using this Newton, this conversion right here. Turn this to, rid of that, and rid of this, and change this to 82.9 newtons per meter cubed. Okay, and then that is our answer for the specific weight. Thanks for watching, soldiers. Don't forget to leave a like and subscribe for more content like this. If you have any questions, leave it on the comments, and if you need help with any other problems, feel free to contact me with the email shown on the screen.